and then you're able to run the Proteus program and run a demo software that I have put into the same folder that you downloaded files from, and see whether everything works fine. Then towards the end, if we had a bit more time, we'll just play around with the software, have a bit of fun trying to create some circuitry in it that you can play with. Okay. Right, so I'll start sharing my screen. You all should be able to see my screen now. And this is the website that, the Google Drive folder that Les shared with. I suppose everyone had access to this. So this link is in the email that Les sent you. Now, if you went there, you would see two PDF files. One file is about how to install Proteus. So you download the Proteus software from here by clicking here, and then it'll download it, press the button to install it, and then as it says in this PDF, you go through the installation process. Is anyone here who's having issues installing Proteus? You could probably send a message that then we can see if someone's having issues with Proteus. Les, is this recorded?
Yes,
Someone's asked.
Yeah, it is. I've just replied.
So everyone's, I suppose, managed to get Proteus installed. Is that fair to assume?
Mm-hmm. Mm-hmm.
Then the next thing is you need to install Arduino. So you go find Arduino. I think Les sent you an link where you can download Arduino from. So you go to arduino.cc, go to software, downloads, and then from here, if you have Windows 10 or 8.1, it's easy. You just click on this button and it'll take you to the App Store and allows you to install Arduino. And because I have a different version of Windows, I usually go here, download it, and install. And if you do that now, you would have Arduino installed on your computer too. So I think everyone here also has Arduino installed in your computer.
It'd be good just to, for people to have some sort of show that they've got it, that part installed, Duleepa.
Yeah. So, so if you had Arduino, then you can, on your start menu, you should be able to see Arduino like I'm showing here. And you should be able to open it up. Try that now, so we can make sure that all of you have Arduino working in your computer. Arduino should open up, and you would have a blank screen. In this case, I have something else loaded, but it should look like this.
Just, it's important to know that the Arduino is the standard programming environment for the Arduino chip. So it's called an IDE, an independent development environment, and that's where you do write the program and then download it into the little chip on the Arduino board. Thanks. Sorry to butt in, Duleepa.
No, that's all good. Yeah. So now the next thing is Proteus. So to check Proteus, there are a number of ways. You can either go here and search for Proteus, or you could just click on the start menu and then find Proteus. So in this case, I have it here. Click on it, and it'll hopefully start running Proteus.
Did anybody have any problems running or getting Proteus loaded? Sean?
I'm downloading Proteus right now. I have Arduino installed because I just received a message.
Oh, okay.
Okay.
Thank you.
Yeah. It shouldn't take that long to download. It's usually 10 minutes to download, I think. Anyone else who's having issues? If you have issues, then what we can do is we can do a screen share, and then I can look at your installation, and we can help you get it sorted out. So like Les said, Arduino is an IDE, which means it's basically, it has everything you need to write the program and sort of get it built, or in technical terms, we call it building, which basically means the program you write, it gets converted into a language the Arduino can read from what you write, because what we write is something what we can read in English. And then this IDE takes that and it compiles it into a bunch of numbers, which the Arduino can understand because the computer can't understand English. And then it basically goes and programs the Arduino when you have a physical Arduino. The Proteus environment, basically because with the lockdown and everything, we can't really have access to an Arduino. And we need to test our software as a use case. So what we use this Proteus environment is to emulate that Arduino that you might be buying from Les or from online store, and trying out the software. You can achieve the same thing on Proteus virtually. Everything's done virtually. It'll work as it is in the real life almost. So you can, without going to the lab, without going to the school, from home, you can build and test everything that you want to do for the Innovation Challenge using Proteus and the Arduino IDE, and make sure that when you go to the lab, everything's going to work as soon as you put it on the hardware. Okay. So that's why it's quite important to have both these pieces of software installed properly on your computer. Anyone else having issues opening up Proteus? Right, so the next thing we are going to do is, in this Google Drive folder Les shared, there's a folder called EVolocity Getting Started. So I would like you to download this now. So you can download it by going onto the folder, and then it turns into a download icon. You click on this, it would start doing something, and then a few minutes, give it a few minutes, press on leave. It'll start downloading it, and now it's downloaded onto the computer as a zip file. So you click on this one, it'll open this zip file and show you the folder. You just drag it onto your desktop for now to save it. If you want to save it into My Documents or somewhere else, that's perfectly fine. Now I'm going to close this.
Is that too fast for people, or are you happy?
Anyone having issues so far? So basically what I did was I downloaded this folder by clicking on the arrow. It takes a minute or two for Google to zip it, download it, and then once it's downloaded, you click on that. It'll unzip it and show you the folder that is inside the file. And what I did was I just dragged it onto my desktop so that I can work from the desktop, but you might decide that my documents might be a better place. It's up to you, completely up to you.
So that getting started is the same as the zip file?
Yes,
that's
in the email, yeah.
Thanks, Duleepa.
So now double click on this. You should find a file called EVolocity demo, and another file called blink.ino.elf. Don't worry about this file. It's just a file that when it's zipped, it created. And then there is a folder called demo code, which has the Arduino software in it. Okay. So the first thing is this one, which called the Proteus EVolocity demo, is the Proteus file. So we're going to now open this Proteus file. So to do that, you can double click on it, but if you double click on it, it'll open up another Proteus window, which will take another license. So it should be okay today because we don't have that many people, but ideally what you should do is you should go here, click on Open Project. Okay, so you click on that, and then you go to your desktop and go to that file folder that you just downloaded, and then you select Proteus EVolocity demo. Everyone's here? Then you click on open. If anyone's having issues, just type it on your chat window and then we will come to you or speak out. Right, so I'm going to just press open, which will take a few minutes, open up this file. Now, this is something I created for you to just get started, understand what Proteus does, and try out a few features of Proteus. Everyone's here? If anyone's having issues, let us know. So someone's putting a thumbs up. You can use the thumbs up button if you're okay. Cool. Right. Nice. Seems like most of you are getting there. Right. So let me tell you what's in here. Now, this is the first task that we're going to look at. Everyone knows what an LED is. So an LED, a light emitting diode, when you put a current through this LED, it lights up. And you can buy multiple colors. You can buy white LEDs, you can buy blue LEDs, you can buy green ones. In Proteus, being an emulator, it can also emulate all sorts of different colors. So if you want to make up a rainbow, it'll have LEDs to make up a rainbow. In practice, not so, because you can't buy all the colors of LEDs. There are only certain colors, so be a bit mindful. But in Proteus, in a simulator, you can do anything. So what we're going to do in this task is take a few LEDs and light them up and see to get a bit of use to how does Proteus work, how does it simulate, and how do we use it for our project. Right, so like I said, to turn on an LED, what you had to do is you had to connect a battery and create a current to flow through this LED. And to control the amount of current, we had to use something called a resistor. Has anyone heard what a resistor is? Can someone unmute yourself and tell me what a resistor is?
I think it controls how much electricity goes through. I'm not sure.
Yeah, correct. It controls how much current goes through the circuit. It basically resists the flow of current, right? So the smaller the resistor, the more the current that flows through the circuit, and the bigger the resistance, the smaller the current that will flow through the circuit. So in this case, I'm using a somewhat small resistance, so I can check how much resistance it is by double clicking on it, and it says 680 ohms for this resistor. Now, if I make it smaller, the LED should light up quite bright. If I make it larger, the LED would be quite a bit dimmer.
If I remove it, it might explode.
Exactly. If you remove it, it will explode because you have a lot of current going through the LED. For a second, it'll light up really brightly, and then it'll explode. Right, and there is a push button here. Why do we have a push button here?
Turn it on and off.
Yeah, so like you do with your switch at your house to turn on and turn off a light bulb, we are using a push button here. When you push the button, it completes the circuit, makes the current to flow through from the battery, through the resistance, through the LED, back to the battery, turning on the LEDs. So it'll turn on all the 4 LEDs I have in this circuit. Now, if I press the button, nothing happens, right? You can click on it. It'll show you that you're pressing it. You can try this out. Nothing happens. No LEDs are lighting up. Now, this is because we haven't still asked Proteus to simulate this. Now, to get Proteus to start simulating, what we have done is so far, we have given it the circuit that we want it to simulate, but we haven't told it to simulate it yet. Now, to get it to simulate, what you have to do is, can you see this blue button, like a play button here?
Yes.
You click on that play button, and it'll start simulating. That's one option. The other option is you go to debug and run simulation. That's another option. I usually prefer this one because it's right in front of you. You click on the blue button, it'll turn into a green button, showing that it's playing, and it'll start doing something in the circuit. Okay, first thing you notice is there's an LED, yellow LED up here that's blinking.
Yeah.
Now that LED is being blinked by the Arduino. We'll come to that a bit later and talk about it. But for now, we are going to look at this circuit here where we have 4 LEDs and we want to use the push button to light it up. Click on this push button, see what happens. All the LEDs light up as you expected, and you let it go, it turns off, right? You can click as many as times, light up, turn off, light up, turn off. Now, we did say that if we increase the resistance, it'll be quite a bit darker. It won't be as bright as this. So let's experiment. I'm going to select the green LED and I'm going to change the resistance. So I'm going to first stop the simulation by stopping, hitting the stop button like you have on your music player. There's a stop button. You press on that, it stops the simulation. Okay, so click that. It will stop everything simulating. Okay, now you double click on this resistor. Then you go here, and I'm going to make this 10 times larger by making it 6,800 ohms. What would you expect?
It will get really dark, or like it won't even turn on?
Yeah, it might not even turn on. It might be really dark, okay, because the current is really small. Let's press OK and press run. Now click on the push button. You could see a faint green color when you do it, right?
Yeah.
You guys see it?
It's basically black.
It's almost black, but there's a slight, if you look very closely, there's a really faint green color.
Oh, I see.
Okay, so basically it limited the flow of current, and you can now experiment. You can stop it again by pressing the stop button, and maybe go here and make it not 6,800, maybe make it like 3,000. Okay, now press the simulate button or the green play button and press on the thing again. Now it's a bit brighter, not as bright as the 680. Now after some point, of course, Proteus can't simulate a device blowing up. Sometimes it complains saying this would be damaging. Sometimes it's not as intelligent. It might just ignore it and say, maybe I wouldn't care about it. Okay, so you have to be a bit mindful. You have to be a bit more cautious about some of the aspects. It can't simulate everything. All right, so I'm going to stop this and I'm going to put this back to 680. And run this and confirm that everything's working as it used to be. Okay, and let's stop this again now. Right, so any questions so far? I'm just, at the same time, I'm reading the chat window just to make sure that we're capturing everyone. So someone's asking a question, can we look some stuff up on how to use Proteus? Yes, there are plenty of videos on YouTube on how to use Proteus. It's a quite famous package. Even people using Arduinos and stuff, you would find quite a lot of videos on Proteus and how to use it. And it's a software that's been around for many, many years. So there will be a lot of videos on YouTube that talks about Proteus and how to use it. But again, for your project, what we will discuss today is more than enough for you to use in your project. Because we will give you all the circuits you need, so you don't have to draw the circuits. The only and the main thing that you need to know is how to run the simulation by pressing the arrow button or the play button, and how to stop the simulation by pressing the square button or the stop button. Those are the two main things you need to know. And then the third thing that you need to know is how to interact like we did by pressing a button, for example. Okay. The other thing that you would need to know is how to use the Arduino in this environment. We would come to that a bit later in the session. Any other questions?
No.
Les, any questions?
I think you're fine. I think when we do a few exercises, the use of it will become apparent and the steps on it. Yeah.
So now, okay, so the next thing is, this is your Arduino or Proteus, what it sort of tries to emulate in Proteus as an Arduino. It's an Arduino Nano, which is more than sufficient for your project. There are many Arduino versions. There's the Arduino Micro, I think. There's an Arduino Nano, and then there's an Arduino something else. Uno, yeah. So there are many versions of them. So for this project, we recommend using a Nano because it's the cheapest you could get, and it's got enough pins, and it got more than enough capability to do your project. Right. So I have already set up the Arduino for you in here, and all the files we will give you for EVolocity would have the Arduino set up, so you don't have to worry too much about how to draw the Arduino, how to put this, and so on. Now, a few things to note. There's a press button here, and this is called a reset. So when you have a computer, anyone press the reset button on a computer?
Yeah.
Yeah. What does it do? It just restarts the computer and restarts everything back to normal again, right?
Yeah.
And it's a good thing if you got stuck or if your computer got hung, then it's a good thing to have the reset button. So this is the same concept in the Arduino. If you want to reset the Arduino, if your program crashed and the Arduino went and did something wild, you just hit the reset button, it'll restart the program again, okay? So that's why the reset button is there. Arduino, when you buy the Arduino Nano, it'll have an LED connected to it. So you can start doing some initial programming just to make sure Arduino is working, everything's fine, kind of thing. So that's what this LED is there for, showing the LED that will be on the Arduino itself, or on the Arduino Nano itself. It'll come with a USB header, which you will plug into this and then plug it into your computer USB port. That's how it basically communicates with the Arduino IDE. So once you plug it into the computer, then you can go to Tools, and in the in the port, which is nothing here because I don't have Arduino plugged in, it'll show you the plugged in Arduino, and you can select it. You can select it's an Arduino Nano, and you can select it has an Atmel processor. And then once you do that, everything you write would be programmed automatically onto your physical Arduino. But because we have this virtual Arduino, we had to somehow tell our Arduino IDE or the programmer that these two this is supposed to send the program to this guy, not to your board because you don't have a board plugged in. It's a bit tricky to get this first set up, and that's why we had a PDF file in the Google Drive explaining how this can be done. Okay.
Yeah.
So the way it is done is when the Arduino, give me a second, I can't see my files now. Right, when the Arduino, when you write the program, so in this case, this is the simple program that basically blinks this LED that's on the Arduino every 1 second. So it'll turn on the LED for 1 second, it'll turn off the LED for 1 second, and it'll keep doing forever, right? So this is a program that Arduino itself supplies as an example. Now, once you open this up, what you can do is, if you had an Arduino connected, you go to Tools, you go to Port, select your Arduino, and then you go to Boards and say that it's an Arduino Nano. And this is by default set up properly. And then you go here and say Upload. When you press that, what it does is, it takes this nice program that's written in English, it converts that to a bunch of numbers, and then it goes and downloads it through the USB connector onto the Arduino itself. Now, of course, we don't have an Arduino. We are using this Proteus to simulate our Arduino. So what we have to do is, instead of hitting the upload button, we have to click on the tick button, which says verify. So when you hit click button, the Arduino programmer goes and what it does is, technically it does something called compiling. Compiling means it goes and converts this program that you have written in English to a bunch of numbers. Okay.
Yeah.
Now, if you have set it up properly, if you followed the instructions, you would have set up a folder called Arduino outputs on your C drive. And then it'll create all these files. Okay. Now, the main file we are interested in is the file called blink.ino.elf, or any file that is basically ending with elf. Equally, the file that ends with hex is also valid. Let's quickly, while we're here, have a look at what's in here. Okay, I'm going to open it on Notepad just to show what's in here. Okay, so you can see it's a lot of numbers, right? You can't really read it. Basically, that's something Arduino created for you when you hit this tick, which calls it verify. Although we can't read what's in here, this is what the Arduino itself can read. Because Arduino is a computer deals with numbers and symbols, and it has all these numbers and symbols indicating what needs to be done. So what we had to do is we had to set up Proteus so that Proteus, the Arduino in Proteus, uses this ELF file so that it can start simulating. And to do that, what you had to do is you double click on this, and over here you had to show where that file is. In this case, I have basically what I have done is I have saved that file into the folder where my Proteus project is. So it's already, when you download it, it's already set up. You don't have to do it. You can directly get it from that Arduino outputs folder that you created from the PDF. Now, if you run this program, that's why you start seeing this LED blinking every 1 second. So 1 second turn on, 1 second turn off, another second turn on, second turn off. Okay, right. So now to start linking this properly, because I have basically done it for you in the same folder, let's set it up on your computer now. Okay, did everyone follow the instructions that gets you to set up this folder Arduino outputs? Did you have a go at it?
Yeah, I'm still working on it, but I think I should be fine. I finished downloading Proteus now.
Okay. Anyone else? So basically, it's following the instructions in this document, which takes you through the steps. Do you want me to do it in front of everyone? Everyone's got Arduinos with you, right? Shall we go and do it together?
Do you mean a physical Arduino or Arduino on a computer?
Arduino programmer, the IDE.
Oh, yeah.
Yeah. Okay, so shall we do it together, everyone?
Okay, I'm writing the server address now.
What do you think, Les? Should we do it together?
Yep, I think it'd be good.
Yeah.
Okay, so
Just do it slowly, Duleepa. Yeah.
Yeah. Okay, so first you click on File. Actually, before you do that, let's go to oops, that's not the one. Let's go to My Computer. Right, you can either type in here My Computer, or you can open it up any other manner from your desktop. Go to the C drive and create this folder called Arduino Outputs. And to do that, what you have to do is you click File, New, Folder. Okay, so you right click, New, Folder, and then you name it Arduino Outputs. Okay, I'm not going to save it because I already have one, but that's how you create a folder. It'll be an empty folder. There's nothing in here. You just call it Arduino Outputs. Okay, I'm going to delete my one because I don't need it. So I already have this folder. Right, now go to Arduino and go to File. I'll wait for a few minutes for everyone to catch up.
Thank you.
And I have this one. Yep. So what we did was we created this folder called Arduino outputs on your C drive. Shall I continue?
Yeah.
Right, so the next thing is you on Arduino IDE, you click on File and Preferences.
Yeah.
And it'll bring up this complicated looking window. Don't worry about anything else. Click on the button, the last part where it has a link. Okay, so here you click on this one.
Yeah.
It'll open up a folder. Okay, now go here, close this. We don't need it anymore. And also close Arduino because Arduino has to be closed for this to work.
Just make sure people do that. It's important. Yeah.
Cool. So make sure Arduino is closed. It is very important to close Arduino. Right. Now, in that folder Arduino opened up, there's a file called Preferences. Double click on that to open. And there's all sort of different information here. Basically, what this does is it tells Arduino what to do when you hit some buttons. Okay. Now, we are interested in telling it to store all the files that it creates in this folder that we created called Arduino outputs. So simply just type this into the second line. Okay, build.path equals C /Arduino output/. It basically tells whatever you build, whatever you verify, put it into this folder Arduino outputs. Okay. So type that in. I'll give you another minute. And once you do that, click File, Save. And close it. Right, now go back and open up Arduino. Go to the Start menu, Arduino, and go to File, go to Tools, and go here and make sure that it's selected as Arduino Nano. This should already be like that. You don't have to do any changes. Then you go to File and go to Examples. Okay, and then you go to Basic Blink.
Yeah.
So everyone's here now? Right, so click on that. It'll open up this exact same file I had since the beginning. Okay, it'll tell that it starts with blink, turns an LED on and off, and so on, so on. Okay. Right, so we are going to, now the program would look like that. So in the Arduino IDE, so this like Les and I explained earlier, this is called the Arduino IDE. There are two parts to the Arduino program. One is the software that you write in the section called setup. So in the setup, you write everything related to your software that needs to be set up. So in this case, what we had to do is the pin the LED is connected to, we need to say, use it as a switch so we can start turning on and turning off the LED. So that's what this one exactly does. Then there is another section called the loop. What do you think the loop does?
Like
What
repeat,
comes to mind, loop?
because the LED turns on and off, and it's kind of like a loop.
Mm-hmm.
So
Correct.
it goes on forever, I think. Yeah.
Yeah, correct, exactly. So the loop, whatever is inside the loop, it starts from here, 1, and then goes to here, goes to here, goes to here. As soon as it comes to the end, it realizes that, okay, I'm in a loop, forever loop, okay? It goes back up here, come here, go there, do that, and then come back up again. So it keeps doing this forever until you either hit your reset button or you disconnect and power off your Arduino. So if you look at this program a bit more closely, what it does is it uses the pin that's connected to the LED, and basically in this case to turn on the LED, what it does is like we used with the push button, pressing it, this basically emulates that exact same thing by setting that pin to high. After that, it just waits for 1 second, 1000 milliseconds. 1000 milliseconds means 1 second, okay?
Yeah.
So basically it's similar to holding that press button for 1 second. And then you let go of the press button by giving this command, which sets that pin to a low. A low basically emulates a push button that you have let go, okay? And it stays there for 1 second. And then comes back up again, push the button, stays for 1 second, let it go, stays for 1 second, push it, stays for 1 second, and so on. So your LED will start turning on, turning off, turning on, turning off, right? Okay, so that's what this program does. Let's go and load this up to Proteus. So if you have done everything correctly, hit this tick, which is the verify button. You put that, what it'll do is it'll say here, done compiling. Now, if you had some mistakes, it'll come up and say, look, you had some mistakes in your program, go and correct it. Now, in this case, I don't have any mistakes, so it said it's all good. Now, if you go here, you would see all these files it created in that empty folder. That's how you could check and make sure you've done everything properly. Can everyone do that? I'll give you a minute. Go to that Arduino outputs folder in the C drive, double click on it. So you go to your C drive, Arduino outputs folder that you just created, and in that, you should have all these files now. Okay. Now we are going to go to Proteus, double click on this, click, now we have to basically tell Proteus that, oops, don't need that one. I had to tell Proteus that my ELF file is here. Now to do that, what you have to do is you have to click on this folder icon and show where it is. Okay, you click on this, you go to your C drive, my computer, C drive, Arduino outputs, and that's the ELF file. Someone's asking what the text should be in the, it's in the PDF. So let me bring it up for you. So this is the part that you had to type it into the text file. build.path equals C / Arduino output /. All right. Right. So what we did was we went and clicked on this folder. We went to my computer, C drive, our folder that we created, Arduino outputs, clicked on the ELF file and say open. Now it's sort of, we had told Proteus, this is where our ELF file is. That's all you had to do. And you only had to do it once. Only time you had to redo it is if you change your Arduino, if you use a new Arduino file with a different name. Otherwise, you don't have to redo this. Press OK. Right, now if you go and simulate this, run simulation, make sure it turns green, it starts running, you would see the LED blinking at 1 second. 1 second turn on, 1 second turn off. Okay, now we are going to be a bit clever and change something, okay? We're going to stop this. I'm going to make this smaller so people can see both sides. This is my Arduino. Right, so if I want this LED to blink faster, what would I do?
Decrease the time.
You had to decrease the time that it stays on and turns off, right? Let's make it 500. So it's every half a second it turns on and every half a second it turns off, okay? I say verify. And now I'm going to run this. Can you say it blinking faster?
Yeah.
What if I want it to turn on for half a second, but only turn off for 0.1 of a second?
I think after the load, we might write.
Yeah, so you
100?
basically change this to 0.1 second.
Yeah.
Right? And you've hit verify. Now you should see it turned on for a longer time and turned off for a very short time period. Can you see it?
Yeah.
Right, so that means whatever I do here get reflected onto the Arduino. It's linked together now, okay? You don't have to do all that complicated stuff anymore. You'd only have to do it if you change the file name of the Arduino, which is what we are going to do next, okay? So I'm going to stop the simulation. I'm going to close this Arduino program. I'm going to say, no, I don't want to save it. Now, let's go back to the original folder we downloaded from the Google Drive, okay? There is a code, a program called demo code, okay? Double click on that. And double click on the demo code. It's an Arduino project that's slightly different to what we did. Okay, so over here, basically what I have done is I have in Proteus, you could see there are 4 LEDs. Same 4 LEDs that you were lighting up with the push button. But in this case, what I'm going to do is I'm going to use Arduino to light these 4 LEDs. And because I can, I'm going to light them up one at a time. So I have this effect where it's sort of scanning from one end to the other end. Okay. Now I do it by turning on one LED at a time and turning off the other ones. So we had to press verify again to change this code into numbers that Arduino can read. And now if I press this here, simulate, it starts saying, okay, there's an error. I don't find your file. What happened was if you went to Arduino outputs, now everything has changed. Because my Arduino code was called demo code, it changed everything into now demo code. So Proteus had an issue because it can't find the LED blink LED file anymore. But what you could do is you just close it and you go here. We know the issue. Oops. Double click on this. I had to go and show this new file again. I had to show demo code ELF, select it, open. Okay, so you clicked on the folder, demo code ELF, open, and press OK. And now you press simulate. You could see now the 4 LEDs turning on at a time.
Yeah.
Okay. If you wanted to go faster, what would you do?
Reduce the time.
You reduce the time, you make it maybe 100 milliseconds or 0.1 of a second. Do you know how fast we can see from our eyes?
Is
Then click verify.
it
Do you
like
think we can see
50?
0.1 of a second? Let's see. What do you see? You can see it, right?
Yeah, we can.
But it's a lot faster. Do you know how fast we can see?
Is it like 50 or 40 frames per second or something?
A bit less, I think. I think it's more about 25 frames per second, because most of the videos you watch, they're in the range of 30 to 60 frames per second, and you don't see the frames, right? Maybe some
Yeah.
of you do. When you do gaming, you start seeing dropping frames and stuff. But usually it's somewhere in that 30 to about 30 frames per second. You wouldn't notice it. We can start making it smaller and see what happens. So I'll make it so 30 frames per second. How much time is per one frame?
30%.
1 over 30th, right? It's hard to divide. 33.
I'm gonna get my calculator.
I think it's roughly 33.
1 over 30 is like 0.033.
Yeah, and in millisecond it's 33, I think, isn't it?
Yeah.
Yeah. So if I now verify this, we might not be able to see this one here.
It's going like forward and backwards now.
Yeah, because Arduino itself is Proteus itself is trying to emulate this, but it doesn't know how to emulate it properly.
Oh, I see.
So that's the limitation of emulation. It can't always do everything 100%. Okay, if I drop this down to something like 3, it might be okay. Now it just shows them all as turned off. So that's the downside with Proteus. You can't always emulate and sort of show nice animations of everything. It still does the simulation, right? Everything's done properly. The only thing that it can't do is it can't show these LEDs as fast as it should be, because your graphic card and your processor can't keep up with that workload. So if you look at down here, it says it's now using 53% of my PC, and I have 8 cores on my PC with each core rated to 3.2 gigahertz. So it's taking a lot of processing power, and in the process, it's just missing out that sort of animation that it's showing you. But everything's simulated properly though.
Yeah.
Right, so you can press stop button. Any questions so far? So someone's saying mine says 3 errors. What are the errors it's showing? Do you mind? Okay. Maybe it's not set up on the Arduino side properly. What we could do is we could maybe you can share your computer screen and then we can have a look. Shall I stop sharing? Then you can start sharing it.
Brad, would you like to?
You can share your computer screen and then we can have a look and see what might be wrong. Can you open up Arduino and let's see if it's set up properly? So it seems like go back to so hit on this top on the top right, top left. there's the tab called schematic capture. Hit on that. Yep, double click on the Arduino. Arduino outputs blank dot. Yep, okay, so that seems to be set up properly. Now we need to go to the Arduino. Can you show the Arduino? Maybe Arduino is not set up for its Nano. Maybe it's a different Arduino. We can't see it, by the way. Yep, go to Tools. Okay, let's set up as a Nano. Yep, yep. Can you, yep. Can you go to the Arduino outputs folder? We can't see it again. Yep. Right now in your Arduino outputs folder, it's demo code. Go back to Proteus. We can't see Proteus again. Yep. Go and click on the folder. Yeah, double click on Arduino. Yep. And select, yep, because when you compiled it, it renamed the file to the demo code file. Yeah, press OK. Now run it. Yep. So every time you open up a new Arduino program that you have written that has a different name, you have to do this. If you use the same file name, it'll be perfectly fine. You don't have to change anything. But if you change that file name, because once we had the file name called Blink, the other one we had the file name called Arduino demo. So every time the Arduino code, the name for the Arduino project changes, you had to redo this process again, because that outputs folder get rewritten by this new file. Okay. Anyone else? So that's good. The Zoom ability to share the whole screen. Yes, it does have the ability to share whole screen. Yep, someone from Glendoby is having a problem.
So now I opened Proteus design suite 8.10, but before it opened, I didn't see a login window.
Do you want to share your screen so we can see what's going on?
Yeah, I will do that. Share screen. Share. Can you see the screen?
Yeah,
Okay.
yeah. So it says it doesn't have. Can you close Proteus?
Close it.
Yep.
Yep.
And restart it again. See whether it would now come up with. Usually, when you first install, you had to restart it again. Yep. Now run it again. Yeah. Now
yeah.
it's EVolocity 2020. Yep. EVolocity 2020, and the password is Auckland Uni. A capital and U capital.
Auckland Uni. Yeah.
Auckland Uni. That seems way too many characters.
Let's try.
Okay.
Maybe it was.
Yeah.
So
It's AAUCK. U capital. Sorry, AUCKLAND. U capital.
Yeah.
NI. Seems to be correct now.
If it's loading, it should mean it's correct. I see. So I will just tell my other friends, like other friends in Gangda College, to restart the app.
Okay.
To
Okay.
log
So
in.
that, yep, that's
Tell
good.
by the bottom left there that you're logged in
Yeah.
properly.
Yeah. If you look at the bottom left, it says it has my name because I'm I'm the person who's responsible for the software apparently. So
Oh,
and
I see.
the university information.
Thank you.
Cool.
Okay.
Anyone else? So I think to conclude, let's quickly sort of go through this and look at what we learned today. So one key thing that we learned is once you have Proteus and Arduino set up, to run a simulation, you click the play button. When you hit it, it turns green and the simulation starts. Okay, so that's key concept one. To stop the simulation, you had to hit the stop button like in your music player. You hit it, it stops the simulation. Okay. The next key thing that we learned about is how to use the Arduino and how to link the code. So we looked at how to set up so that when we hit verify on the Arduino, it stores all the outputs to this folder we created, Arduino outputs. So to link it, third key concept, you double click, select the folder that you just created, go to C drive, Arduino outputs, and select the ELF file that Arduino generated and press OK. Once you do that, it linked your Arduino file to your Proteus file. And then you can simulate it. It'll start doing what you asked it to do. So in this example, if I change this back to 300 or something sensible, oops. And the fourth key thing is you had to press verify so that Arduino goes and takes your nice software and compiles that into the numbers the Arduino can read. And now if I hit run or simulate, it'll start showing what the program would do in real life. And you can press stop. Now what you could do is, for fun, you could try doing all sort of different things. If you need more LEDs, there are LEDs here. So let's say I want to press the blue LED. I click on this, I can place it. Okay, if I want an orange LED, I can click on that and I can place it. If I want a resistor, I can click on the resistor and then I can place this resistor. Now, if you want to rotate this resistor, what you have to do is you right click on it, say rotate. Okay, and then you can drag it anywhere you want. Let's say, for example, like this. I'll add another resistor and rotate. Okay. Now to connect them up, as soon as you come close to the device, it turns into a pencil. You just connect them up together like that. Okay. You can connect these up together like this. And I'm going to be lazy. I'm going to just connect this one to the battery like that and connect this end to the other side of the battery. Connect them up. Okay, so I added two more LEDs. Now if I run this and press the button, I have two more LEDs lighting up. Okay, now you could start doing what I would recommend is from home, because the whole idea about learning how to use Arduino, change this what I have done here, which has LEDs going from one end to the other end. Now make it go like that way, okay, up and down. Have you guys seen this TV series called Knight Rider? It used to be a very old, Les probably can remember it.
I do remember.
Yep. I don't think the young kids these days have seen it before.
I don't think so.
Probably all your teachers probably have seen this. Do you think we can show them a quick video?
That'll be good.
Let's see, YouTube. So it's a story about a really cool car. Okay. It's about this car. It has this cool light at the front. If I can, might try to.
That car looks cool.
So here we go. If you can make that happen in Proteus, that will be awesome.
Whoa.
And this is completely possible with an Arduino. You can even take it to your own car, buy some LEDs and make it happen.
Have whatever color you want to.
What's that?
And have whatever color you want to.
Exactly. Yeah.
In my day, it was only ever red.
Yeah.
Yeah, maybe I
The
can add
Night
it to
Rider one,
the wheel.
original one, is only red, and it comes with this really nice sound track. Okay, sound. You can create this using your Arduino as well. Let's see. With the, can you guys hear the sound?
Yeah. Oh, that's a nice car in the background.
There you go. So you can search up Night Rider on YouTube and you'd get plenty of, this used to be a big thing in the old days. Everyone liked to build their own Night Rider set of light bulbs and the sound and put it on their cars as a gimmick. So when I was a kid, I used to do it. So it's an interesting, nice trick you can do with an Arduino. You can try it out on the Proteus and see whether it works. Okay.
Yeah.
Right. Any other questions?
No, but by the way, I have Arduino Nano at home. So
Oh, cool, nice. Yeah. So you can. Do you have a breadboard?
yeah, I do, and I also have like jumping leads LED.
Okay, that's nice. Yep. What you can do is you can simulate everything in Proteus, and once you know it's working, you can transfer that software into your Arduino, and it should start working as you expect. And this is very important because if you decided to become an engineer, these days engineering is all about first coming up with the ideas, then using a simulator to simulate it, because in a real engineering project, you can't afford to have the real hardware in the first time because you might have made a mistake in your software or you might have made a mistake in your design. And with expensive hardware, it will blow up thousands and hundreds of thousands of dollars worth of equipment. So what you usually do is you simulate everything, make sure everything works, and then go and use the hardware to test it. So yeah, careful not to blow up, damage expensive equipment.
Yeah.
Any other questions? So everyone seems to have gotten a flavor of Proteus. So next time we will start learning a bit more about Arduino programming. I'll start from very basics. Today I just sort of gave you a very brief idea about programming, but next time we will talk about it slowly, step at a time, and understand how to write a simple program.
Yeah. I have one question.
Mm-hmm.
Will we be able to get the recordings of today's meeting?
Yes, Les has recorded.
Okay.
Les, you're on mute.
That's good. Yeah. Just to make sure I don't miss any detail.
Yeah, sorry, I did switch myself off while I was taking that call. I have recorded it and I'll make it available as long as I've got your email addresses. There's just a few things from me. Duleepa is using a product called Piazza with his students. It allows people that are enrolled into it to share code and share problems and have a really good environment for doing personal help. And you can share screenshots and that as well in it. So what I'd
That's-
like to do, if I've got all the email addresses, is enroll people into Piazza so that we can try and keep in contact with you and solve any problems.
Yeah, that's one way. The other option is, Les, since you have recorded this, we can put it on YouTube and then use the YouTube question and answer sort of thing as a post. So every video would have its own sort of YouTube posts where you basically answer them.
Yeah.
In that I don't know which are all the students familiar with YouTube? Like, so you can have these sort of comments, and then we can reply to it saying this is how you do it. Is that something that might be good for you?
I've never used that on YouTube. Is it a free service, Duleepa?
It is a free service, yeah.
Okay, no, that whatever works for people, I'm quite happy with.
Yeah, Piazza, I can open up Piazza here if you want to see. Piazza is also a forum that we very widely use at the university. So you basically can go to an example. It's just basically like a forum. You just ask questions and we can basically enter answers to those questions. But since we have videos for each lesson, YouTube might be a better way to do it, because then it could be questions related to the YouTube. And I'm pretty sure everyone's in this thread would have used YouTube and are familiar with YouTube, right?
Mm-hmm.
Yeah.
Everybody happy with YouTube as a sharing mechanism? Just say if you're not. Okay. That was one thing I wanted to get out of the way. The other thing is that there's a lot of students who weren't able to access this tonight, and they've got sport and other things that they had to get away to and jobs. I just wonder whether we can repeat it, and that may be of interest to some people that have sat through tonight and weren't quite there. But whether we can repeat it on Monday night.
Yep. Yeah, I'm happy. What time Monday, Les?
Well, if we cut into the day, the availability of everybody will be different. But if we did it at, say, 4 o'clock or 3:30 in the afternoon, we're probably going to get a different group of people.
Monday 4 to 6, I do have a class.
What about Tuesday?
Tuesday is fine. Tuesday is quite free for me.
So
Monday next week is the only problem. After that, we have finished teaching for this year.
So Monday's all right from then on, is it?
Monday's all right from then onwards, yeah. Tuesday 1 to 3 is the only meeting I have. So after 3 o'clock or before 1 o'clock is fine on Tuesday.
Okay. Well, what say we go for Tuesday? Is it too big a delay after school finishes to do 4 o'clock, or would you rather 3:30? Be good to get some feedback, people, so don't sit there and say nothing.
Oh, it's good to have it at 4 o'clock and stuff.
Thanks, Kevin.
I think 4 gives people a nice little break in between when they finish classes before they start the next bit of working. So 4 is good.
Okay. Well, look, I'll put an email out to say to that effect, inviting people to a Zoom session 4 o'clock Tuesday. It'll basically be a repeat of this, so catch up for people, and you'll have a chance in between times to test the connections, test some of the ideas that Duleepa has gone through today, and if they're not working, you'll have time to get answers to the problems. Is that all right?
Les, also, do you have a YouTube channel for EVolocity?
Not at the moment, no.
Okay, so what we can do is, if you have a bit of time after this, I can help you set up a channel.
Yeah.
And then you can upload this video once you download this.
That'd be cool.
Yeah.
Okay. the other thing is, we might do Thursday, Tuesday for the rest of the sessions, if it proves suitable, because I think what we need is some learning, some time to practice, and then some more learning, and a bit of a recap on what's happening. Duleepa has put a schedule together for this, and it's a very generous allocation of his time. So if your mates haven't got online tonight, encourage them to come along, and we'll try and make sure that all the gaps in any learning or the pace is actually suited to what you're doing.
Yeah, and we try to make this video available by tomorrow, so you can re-watch it and sort of go through it again. Make sure, and anyone who hasn't been here, also look at it and then try to set up as much as they can before Tuesday. And if you had any friends in your classes who might be keen to try it out, who might not be doing EVolocity, grab them, come along, and then we can help them learn a bit of Arduino as well.
Yeah.
So if you go through that email that I sent out, it does all the connections. It allows you to get into Arduino. It allows you to load Proteus and then connect the two as well. So if you've got, make sure you've got that done by Tuesday night if anybody didn't have it done today. That's cool. There's a lot of learning in there, and good on you for sticking with it. I think that it's the software is very powerful. Once you get used to using it, some of the things that seem difficult today will seem second nature in about a week or so's time. So stick with it.
Cool.
Great to see you all.
All right, thank you.
Yeah.
Okay.
Thank you for the lesson.
Okay. It'll be just EVolocity tutorial 1, Arduino 1 or something like that on YouTube if you're searching.
Yes.
All right.
Yeah.
Thanks, people.
Or maybe,
Oh, sorry.
or maybe like you can email us the YouTube channel. So in the future, we can just search for the YouTube channel. Like
Yeah.
there'll be a link.
Yep.
Yeah, seems like this. Thank you.
Cool. Thank you.
All right, bye.
Thank you, Les.
Good to see you. I'll just capture this before I forget about it and lose it. You there still, Duleepa? Oh. See you, Kenny. Duleepa.
Hey, you want you tell I can show you how to do it?
Yep. Yeah, that'll be cool. I'll just finish this and where are we?